These are the strangest and most outlandish science experiments that went horribly, horribly wrong. This is the story of a man who stuck his head in a particle reactor. Employed at the Institute for High Energy Physics in Protvino, Russia, Anatoly Petrovich Bogorsky was doing his shift at the U-70 synchrotron particle accelerator when some of its equipment malfunctioned on July 13th, 1978. The failure of multiple safety measures led to the absurd incident that ensued. Bogorsky stuck his head into the operational particle accelerator, exposing his brain to a 76 giga-electron-volt proton beam. The Centers for Disease Control asserts that exposure to 120 rads of absorbed radiation may lead to death in some individuals, though the dose generally agreed upon is LD50, causing 50% of individuals to die at 400 rads. There's only a handful of rare cases in which exposure to 1,000 rads or more has not been fatal. When Bogorsky stuck his head into the particle accelerator, he exposed himself to more than 200,000 rads, and he lived. In fact, there's no record of his death, leading many to believe that he might be alive still. As of today, he would be about 82 years old, but he didn't escape the incident intact. Being the only human alive known to have stuck his head into a running particle accelerator, Bogorsky was studied extensively in the years that followed his incident. Bogorsky, having some recollection of the accident, said he saw a flash brighter than 1,000 suns, but felt no pain. The beam burned through his skull and brain tissue, leaving vast damage to his occipital and temporal lobes. Though having little to no reported impact on Bogorsky's intellect, he did earn himself a PhD following the incident, and he said he feels mentally fatigued more easily now. The incident paralyzed the left half of Bogorsky's face for 2 years and made him deaf in the left ear. Bogorsky is now prone to seizures. Intriguingly, the left half of his face has shown little signs of aging after the accident. So, what are the implications of this incident to aging research? It is a popular theory among biologists that part of the reason why people age is the damage our bodies absorb over decades from background radiation. With this in mind, what mechanism exactly was responsible for stopping the effects of aging on a man's face after he received a dose of radiation hundreds of times more than that which is considered lethal? There's little information about the state of Bogorsky nowadays. Is he alive? Is he even doing all right? Bogorsky may have been studied extensively, but at the end of the day, the tale of the man who stuck his head in a particle accelerator leaves us with a few more questions than we have answers. In psychology, there's a concept known as behaviorism. It's an approach that assumes all behaviors are responses to certain environmental stimuli. It's based on the knowledge that reinforcing a behavior encourages it, while punishing it diminishes it. So, from 1961 to 1963, psychologist Albert Bandura conducted a series of experiments now known as the BoboDoll experiments. These experiments challenged behaviorists by asserting that behaviors can be learned through imitation. More specifically, the central question was, are aggression and violence learned behaviors? The experiment was simple. Young boys and girls would be selected and then segregated into control, aggressive, and non-aggressive groups. The children in the aggressive group would observe an adult verbally and physically harass a BoboDoll. In contrast, the children in the non-aggressive group would see the adult model playing with the doll. The children were then left seemingly alone and allowed to interact with the BoboDoll themselves. Their behavior was then observed. Additionally, Bandura would test this experiment 2 years later, with the adults being rewarded or punished for their aggressive behavior towards the doll. The main experiment's subjects were 36 boys and 36 girls, selected from Stanford University's nursing school, and their average age was 4 years to 4 months. Each group consisted of 24 children, 12 boys and 12 girls, and the groups were further separated, with 6 children of each gender exposed to a model of the same gender, while the other 6 were exposed to a model of a different gender. After being individually tested, the children were exposed to the BoboDoll alone, and a combination of aggressive and non-aggressive toys. The results were as follows. Boys imitated same-gender models more often than girls. Girls with male models were more physically aggressive, while girls with female models were more verbally aggressive, though girls overall tended to be more aggressive verbally than physically. Children with a violent model were likely to imitate the exact behavior that they observed. Boys who observed a different gender model behave non-aggressively were more likely to exhibit violent behaviors than boys in the control group. Boys who observed male models act violently were more likely to exhibit violent behaviors than those who watched female models act violently. And in line with Bandura's prediction, boys were indeed confirmed to show more aggressive behavior than girls. Overall, 270 instances of aggression were observed in boys compared to 128 in girls. In his follow-up study, Bandura concluded that children who saw the adult models being rewarded for their violence were more likely to show violent behaviors themselves. In contrast, those who observed the models being punished for aggression were less likely to show aggression. Although the experiments seem conclusive, there are some well-founded criticisms of them as well, those including that the children were chosen from a narrow pool, being somewhat similar in their racial and socioeconomic backgrounds, creating selection bias. The results were also collected immediately, making it difficult to analyze long-term effects, and non-human dolls were used. Acting violently with a toy is different from acting violently towards a human. What can be learned from this is that although behaviorist ideals certainly did affect the experiments, when children saw models being rewarded, punished for violence, it is still arguable that children and humans can pick up a behavior through observation alone, setting a precedent in psychology. We've all heard about the recent tragic Boeing plane crashes, but this is a little-known story of the time that Boeing crashed one of their planes intentionally to make airlines safer. Known as the Controlled Impact Demonstration, or CID, it was a venture undertaken by NASA and the FAA to obtain data from an intentionally crashed Boeing 720. One of the experiment's main goals was testing the fire-suppressing fuel additive FM9. When FM9 is combined with jet fuel, it creates an anti-misting kerosene, which is known to deter ignition and flame spread. The experiment also used crash test dummies and full-scale anthropomorphic test devices, or ATDs, which simulate human bodies accurate to height, weight, and dimensions during controlled traffic collisions. It took NASA and the FAA 4 years to prepare the crash test. The aircraft went through 14 test flights, during which engine performance was tested, remote piloting techniques were perfected, and the blend of anti-misting kerosene was tested and enhanced. So NASA and the FAA began preparing the crash site where the plane would finally be destroyed. It included 8 cemented cutters, nicknamed rhinos, to slice the wings open without harming the fuselage. The day of the test finally came on December 1st, 1984. The 720 took off from Edwards Air Force Base in California and headed to the crash site. The pilot was remotely flying the plane that day, and moments before the crash, the aircraft had steered slightly to the right of the desired path. The remote pilot tried correcting course as much as he could, but it was too late. Data acquisition systems were on, and the aircraft was committed to crashing. The wings were meant to be level at impact, but the left wing was low, making first contact with the ground during the crash. When the aircraft smashed into the ground, one of the rhinos sliced through the right wing, cutting through the fuselage and into engine number 3. The engine kept running for 1/3 of a rotation, providing a heat source and igniting a massive fire. The fire completely undermined efforts to test the anti-misting kerosene and took over an hour to put out. Despite the failure of testing FM9, NASA considered the test a success due to the crash data that was collected. It's been estimated that 23 to 25% of the 720's capacity of 113 people would have survived the crash, about 30 people. The test also made flying safer, as the FAA changed 2 requirements based on the results. They implemented new flammability standards for seat cushions and required mechanic fastening for floor proximity lighting, as the adhesive ones used during the test appeared to have been detached. So that's the time we intentionally crashed a Boeing 720 to make airlines safer. Typically, when medical procedures are performed, we hope the mortality rate is 0, but that isn't always the case. In fact, while you might imagine that a mortality rate can't ever be over 100% for a procedure, one doctor actually managed to perform a surgery with a 300% mortality rate. That doctor's name is Robert Liston, and this is that story. Robert Liston was a surgeon from the times before anesthesia, which made the job even more difficult. One of the best ways to do surgeries back then was to just go as fast as humanly possible. That's less pain for the patient over a smaller amount of time. Robert Liston was one of the fastest surgeons in the world, even having the nickname the fastest knife on West End. Liston was famous for quick amputations, where he only lost 1 in 10 men, where most surgeons at his time period would lose 1 in 4. Liston could famously amputate a leg in about 2.5 minutes, even performing 1 amputation in just 28 seconds. Before every surgery, Liston would say, "Time me, gentlemen," which became his iconic catchphrase. However, not all of Liston's surgeries went according to plan. He was performing a leg amputation on one patient and was so laser focused on being fast that he forgot his assistant had hands. In his first swoop, he took off his assistant's fingers along with the patient's legs. Realizing his mistake, he quickly jerked the knife upwards, on its way, snagging a spectator to the surgery's coattails. The spectator died on the spot, later to be found from shock. Liston finished the amputation successfully, but the patient and Liston's assistant's wounds became severely infected and both soon died. Liston successfully, or unsuccessfully, had just performed the deadliest surgery on a single person in history. A surgery on one person that resulted in the deaths of 3. It's the only surgery with a recorded mortality rate of 300%. Liston did continue practicing amputations, and he was still one of the best. However, he had a number of other mishaps. In another amputation, he did make the cut just a tad bit too high in his excitement, accidentally cutting off one of his patient's manhood along with his leg. Rather unfortunate. He also mistook a lump in a boy's skin as a skin tag, and after removing it, he discovered it was actually an aneurysm of the carotid artery, and the boy died. Later on, Liston became one of the first surgeons to operate with anesthesia, and died a distinguished surgeon. The Boy Scouts usually teach you how to tie knots or maybe start a fire, but one Boy Scout decided to take his survival training just a little bit further. Nicknamed the Radioactive Boy Scout, David Hahn at the age of 17 attempted to create a homemade nuclear breeder reactor in his mom's backyard shed in Michigan. He was fascinated with chemistry from a young age and spent most of his early years conducting amateur chemistry experiments, which would often lead to small explosions panicking neighbors. Throughout his childhood, he collected raw elements of the periodic table, taking an often peculiar interest in those of radioactive nature. He amassed radioactive material like americium from smoke detectors, radium from clocks, tritium from gun sights, and thorium from camping lanterns. Using a block of lead as the casing, he bored out a large hole to hold the radioactive material and used lithium from batteries he purchased to purify thorium using a Bunsen burner. His reactor progressed into potential functionality. Hahn would often pose as an adult scientist in letters to gain the help of professionals and often to get access to otherwise restricted samples of radioactive isotopes. At the pinnacle of his conquest into the construction of the nuclear reactor, his homemade breeder reactor started emitting dangerous levels of radiation, nearly 1,000 times the average background radiation. It never came close to reaching critical mass, but Hahn began to dismantle his experiments quite quickly. In a random encounter, actually, the police discovered his activities, which eventually caught notice of the FBI and the Nuclear Regulatory Commission. In 1995, the EPA even declared his mom's house a Superfund cleanup site. Hahn's mom feared that the EPA was going to take her home, so before officials could investigate, she took most of David's radioactive material and dumped it in the trash for disposal at the local dump. Officials didn't become aware of this until long after the cleanup had started. So, unfortunately, nothing was done to prevent possible contamination from his large mass of material. As for David, he refused medical treatment after the incident and was never charged with a crime. The rest of his life was depressingly troubled, with David eventually being charged with larceny in Michigan for stealing radioactive material from smoke detectors in his apartment building. In his mugshot, his face was covered with sores, indicating exposure to large amounts of radioactive material over time. After a 90-day stint in jail, Hahn was evaluated for psychiatric problems until his death in 2016 due to alcohol poisoning. The life of the world's only radioactive Boy Scout was particularly troubled, but it makes for an interesting mark in the history of amateur nuclear research. Not typically a term that you casually hear. At least to the knowledge of the general public, no other incident has ever occurred around somebody creating their own nuclear reactor. This is the story of the only time in human history that a nuclear state had its nuclear keys activated and was fully prepared to launch a nuclear strike against an enemy. In 1983, the Soviet Union was in full alarm. Their nuclear early warning system had reported a nuclear strike incoming from the United States. The decision of whether or not to launch a retaliatory strike ultimately came upon a man named Stanislav Petrov, who violated Soviet protocol when he reported it as a false alarm. In doing so, Petrov might have prevented an all-out nuclear war between the US and the Soviet Union. But this was not the only time the world had a close call with nuclear war. After the collapse of the Soviet Union in early 1995, American and Norwegian scientists wanted to study the Northern Lights over Svalbard. To achieve this, they launched a Black Brant 7 rocket carrying research equipment from northwestern Norway. The rocket flew over the same air corridor that a US missile would fly if it launched from the Minuteman III nuclear missile silo in North Dakota towards Moscow. The scientists notified 30 countries, including Russia, of this experiment. Despite this, because Russian radar operators had not been notified, they saw this single missile as a potential high-altitude nuclear attack from the United States. This looked like the first stage in a surprise strike because such attacks generate EMPs that can blind Russian radar to other incoming missiles. The Black Brant 7 reached an altitude of 1,453 kilometers, or 903 miles, similar to that of a US Trident missile. Russian nuclear forces were again put on high alert. The situation escalated even further to such a degree that the Russian nuclear briefcase, the Chaget, was brought to President Boris Yeltsin. He had 10 minutes to decide whether or not to launch a retaliatory strike against the United States. Yeltsin activated his nuclear keys during this time, the only known time any nuclear weapons state has done so in history. After waiting out 8 minutes, it was determined that the rocket was not headed towards Moscow, and a retaliatory strike was called off. After going through such a close call and understanding that it was notified of the experiment, Russia updated its notification and disclosure protocols to prevent such an event from happening again. This episode came to be called the Norwegian Rocket Incident. There have been a few well-known instances in which the world was on the brink of nuclear war, including the Cuban Missile Crisis and the Stanislav Petrov incident. However, this lesser-known Norwegian rocket incident stands out as the only one in which a nuclear state had its nuclear keys activated and was fully prepared to launch a nuclear strike.